Okay, so let's proceed again. So we are from doing this particular question. Now we move on to question D, which is the last part. Okay, so question D1 and D2, that's the last part for binary for test 2. So here we are saying subtract the following numbers in 2's complement using an octet. So an octet is the same as 8 bits. Okay, so nothing has changed. So remember, we already know about 2's complement, and at least now we understand about subtraction, so nothing will change. So we are given 70 and 32. 70 minus 32. So let's start. 70, is it 72 or 70? 70 minus 2. Sorry for that. 70 minus 2. So we have 70 minus 32. Okay. Hope it's okay. 70 minus 32. Now remember, the first step is to come up with the an octet in this case, which is 8 bits. So we say 1 times 2 times 2. So you're just doing times 2. So now this is something which we all understand by now. So I don't want to waste much of the time here. So remember, in subtraction we said we need to follow certain rules. So the rule for subtraction in binary is that this sign will change to positive. Then if we put brackets, it's the same as we have positive 32. So it will change to negative 32. So this is the thing we'll be following. Now you can see that 70 is still positive, so it's not affected by a complement, in this case 2's complement. So what we'll do is that we'll start with 70. So for us to get 70, we have 64 plus 8, which is, oh, not 8 because that's 72, sorry. So we have 64. We have 64. Okay, 64 plus 4, which is 68 plus 2, 70. So this is our 70 in binary. Okay, it's not affected by 2's complement because it's a positive. Now we have the number which is affected, which is negative 32. So first we convert 32 into binary. So to convert 32 into binary, just put a 1 where there's 32. Then the rest are zeros. Okay, as simple as that. So this is our 32. So let's just finish these zeros there. Now, in order to get our 2's complement, remember we say 1's complement plus 1. So let's convert this number into 1's complement first. So we change these zeros into 1's. So this is a 1, 1, and we change the 1's into zeros. So they will be like this now. Okay, now remember this is just 1's complement. We need to say plus 1 to get 2's complement. So we say plus 1. So let me just use black now. So what is 1 plus 1? We have 0, we carry a 1. 1 plus 1, we have 0, we carry a 1. 1 plus 1, we have 0, we carry a 1. 1 plus 1, we have a 0, we carry a 1. 1 plus 1, 0, we carry a 1. 1 plus 0, 1. This is just a 1. And this is just a 1. Like that. So we have our 70 and we have our negative 32 in 2's complement. Now we just need to follow this thing here. So we have 70. So we just display our 70. So our 70 is 0, 1, 0, 0, 0, 1, 1, and 0. Now we come to our final product for negative 2 in 2's complement. We have 3 1's and the rest are zeros. Okay, now remember this is now positive, meaning we are adding, despite of the question saying subtract. So let's come out to the output, the final answer. 0 plus 0 is 0, 1 plus 0 it's 1, 1 plus 0 1, 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 1 1, 1 plus 1 is 0, carry 1. Okay, 1 plus 1 it's a 0. Now because this is 2's complement, we ignore that carry, because 1 plus 1 it's 0 but carry 1, so we just get rid of that one we are having. Okay, we just forget about it. So this is 2's complement. So another rule, and this is our first time encountering it for now. So let's just ask ourselves a question: what is 70 minus 32? So that we confirm something. 70 minus 32. So we borrow a 1, this becomes 6, this 10. So 10 minus 2 it's 8, then 6 minus 3, so again we have 3. Okay, 6 minus 3 is 3. Okay, so 38. Okay, so here we have 38. So let's try to convert 38 into binary. So again we can do it first. So here I'll just show you, since we are trying to convert 38, remember this is 32, so 32 plus this is 36, then 38. So it's the same as we have a 0 0, then 1 0 0 1 1 0 for us to get positive 38. Okay, so let's try to confirm the answer. You can see we have 0 0, that's 0 0, 1 0 0, this is 1 0 0, 1 1 0, this is 1 1 0. So we've confirmed that the answer is actually genuine. So at first, for us to determine whether an overflow has occurred, we say what is the bigger number between 70 and 32 is 70. So for 70 we started here, so we put a demarcation before the 1. So the same applies to this, we put a demarcation. So this is the sign and this is the magnitude. So a 0 represents a positive sign. So we can see here we are expecting a positive, meaning an overflow hasn't occurred. So let's just master the answer. Confirm 0 0 1 0 0 1 1 0. Okay, we are starting with 0 0, then 100 1 110, 0 0 100 110. Okay, let's see. 0 0 100 110 38. Okay, so here I want to talk about an overflow occurring, because what we expected is what we've obtained. So thank you for watching this video. My name is Asuko James, representing KMU Cybersecurity Tutorials. So this marks almost the end of CYS330 test 2 answers for binary. So the coming video is the last video in this test 2. So